Alright, today we're going to work with quadratic equations. We're going to work with differences of squares. Okay, this is the resulting product is what we call the difference of two squares. So if you have something like this where it just says a squared minus b squared, it splits into this, which is the first thing plus the second thing times the first thing minus the second thing. Alright, so if I have x squared minus 25, then I would get the first thing plus the second thing times the first thing minus the second thing. Right? The square root of the first versus the square root of the second. Alright? Easy enough. Any questions how to do that? So it's going to say factor the polynomial. 16h squared minus 9a squared. So what I do is I square root the first thing. So what's the square root of 16? 4. What's the square root of h squared? H. And I plus, and then I do 4h minus. What's the square root of 9a squared? 3a. So plus 3a minus 3a, and I'm done. 121 minus 4b squared. So the square root of 121 is 11. So I'm going to do 11 plus and 11 minus. And then the square root of 4b squared would be 2b. So I put that there. And there's my answer. Now, when I do this, something you have to look for is there a common factor? Is there anything I can always factor out? Just like yesterday, if you weren't looking for something to factor out, that made your life a whole lot harder. Just today, same thing here. These aren't g cubed and g. These aren't squares, are they? Right? 3 is not a square. But I can make them squares because there's something I factor out. What could I take out of 27g cubed and 3g? I could take out g. But is 3 a square? No, so I need to factor 3 out as well, right? It comes out 27. 27 is not even a square. So I'm going to make it 3. So I take 3g out. What is 27g cubed if I took 3g out? 9g squared. And then minus 1. Is this the difference of a square? Is 9g squared a square?
Yes.
9 is a square. G squared is a square. Is 1 a square? 1 times 1 is 1. So 3g stays on the outside, and I do 3g plus, and I do 3g minus, and that's 1 and 1. So there's your answer. So if you were to FOIL this and distribute that, here's what you would get. 9x cubed minus 4x. Right now, one of them's not. Both of them are not squares. X cubed and x are not squares. How could I make them? How can I make this a difference of a square? I take x out. It's the only thing that would factor out. I'm left with 9x squared minus 4. Both of the. Is this a difference of a square? Yes. The 9x squared is a square, and 4, that would be difference of squares. So that would be 3x minus, or we go plus 2, and that would be 3x minus 2, and then remember the x out in front, and there's your answer. B to the 4th minus 16. They're both squares, so I can factor it. B to the 4th minus 16, so b squared plus the square of the first one, and then b squared minus the square of, or the square root of the second one. Which, do you guys notice anything? I can do the difference square for b squared minus 4. Could I do it for b squared plus 4? No, but is this a difference of squares? Yes, so I can do it again. Sometimes you have to apply it more than once. You have to do this more than once. So this would give you b plus 2, and this would give you b minus 2. And you write what's left out in front. B squared plus 4, B plus 2, B minus 2. If you were to work all that out, you would get B to the 4th minus 16. Any questions? All right, you guys do the next one. 625 minus x to the 4th. That's a different square. 625, the square root of 625 is 25. So I have 25 plus x squared and 25 minus x squared, which, if you don't notice, this is a difference of a square, of squares. That becomes 5 plus x and 5 minus x. And you combine that, and there's your answer. All right, now sometimes it'll say factor the polynomial, but you won't always have difference of squares. Sometimes you do, sometimes you won't. Sometimes you have to use other stuff that we've learned. So what they've done is they've kind of combined everything we've learned about factoring to this lesson. So sometimes you'll see different squares, sometimes you won't. Here, 5x to the 5th minus 45x. I'm going to take 5x out. That leaves me with x to the 4th minus 9x, or minus 9, sorry. That's the difference of squares. So, x squared plus 3 times x squared minus 3. Is there anything else I can do? What can I do?
You can.
No, there's not. 3 is not a square, is it?
No.
No, so I cannot do anything else. I am done. Is there anything I can take out? 7. Clearly take out 7. That leaves me with x cubed plus 3x squared minus x minus 3. Everybody agree?
Mm-hmm.
How would I solve a problem like this? Group them. Just like we learned yesterday. We did yesterday. So what, Richard, can I take out of x cubed and 3x squared? X squared. That leaves me with x plus 3. So I want the other one to look like x plus 3. Richard, what would I have to take out of negative x and negative 3 to make it x plus 3? You can't take x out of 3. But you said negative x, so you're thinking right. It's not with x. Negative what? Can't take negative 3 out of x. There's one thing you could take out of both of those.
Positive x? No, I'm lost.
How about negative 1?
Why?
Because right now, the reason I take out negative 1 is because right now it's negative x minus 3. Is that the same thing as x plus 3?
No.
So if I took out negative 1 out of negative x, what would be left, Richard?
No,
If I took negative 1 out of negative x, what would be left?
x.
X. If I took negative 1 out of negative 3, what would be left?
Negative 3.
Positive 3. Good. So now I combine here and here. And then I combine here and here. Which I'm going to do those first. I'm going to do x plus 3 first. And then I'm going to do x squared minus 1. Kyle, am I done?
Yes.
No. Why am I not done, Kyle?
I don't know.
Caleb, why am I not done?
No idea.
Savannah?
Because it's not the same. Like, isn't it supposed to be?
Oh, it's x and x squared.
I have x squared minus 1. Is that a difference of squares?
Yes. No. Yeah.
Yeah.
Could I break it up?
Yeah.
Okay. The reason I wasn't done is because I haven't completely factored everything. This is something I factor. X squared minus 1, you can factor into x plus 1 and x minus 1. Just because it's 1 at the end doesn't mean you can't factor it. 1 is a square. Right? Everything else is factored out as completely as possible. Which there's not supposed to be a space there, but you'll figure it out. So the answer is 7 times x plus 3 times x plus 1 times x minus 1. Alright, here's the problem. 2m cubed plus m squared minus 50m minus 25. What do I do first? Is there anything I can take out of all 4 of those terms? You can't take out m because m is not a part of 25 there at the end. Can't take out 5 because it's not a part of the 2 or the m squared, right? So is there anything I can take out? So now I do what? I would group. What could I take out of 2m cubed plus m squared, Sky? Just m? M what? Not cubed. The smallest, right? M squared. Which would leave you with what?
That would be 2m plus n.
If you took m squared out of m squared, what's left?
Oh, nothing.
Not nothing. That's 0. 1. And what can I take out of negative 50m and negative 25, Sky?
5.
You can take out more than 5. Take out the biggest thing you can take out. I would, not just 25. You can't take out m because m is only part of one of those 2 terms. But I need to factor negative 50m and negative 25. And I need to change it to 2m plus 1. Negative 25. Which would leave me with what?
25.
50 divided by 25 is
2.
2.
And plus.
Okay, remember, it has to be exact to this, right? For me to combine them, they have to be the same. So now I combine the outer 2 terms, and I combine the inner 2 terms, or the ones in parentheses. Now what? Am I done?
No.
Why not? There's difference of squares right there. M squared minus 25. So that becomes m plus 5. That becomes m minus 5. And then 2m plus 1 is left. Usually that's at the beginning. If you're checking the back of the book, it'll be in the beginning. But either way, there's your answer. Here's your homework assignment.